There are moments the cosmos seems to stutter, like a breath caught between heartbeats. Moments where the sky holds its shape too long, where memory flickers without cause, where the air feels borrowed from a place never known. These aren't just tricks of the mind. They are the fingerprints of something else, something vast, something other. Across the great velvet span of the observable universe, space stretches smooth and endless, a sea of galaxies drifting like embers in slow collapse. But sometimes, even this infinite ocean reveals strange currents, unexplained distortions, empty zones, cold regions that defy the rhythm of cosmic background heat. Places where physics does not break, but bends. The known laws are delicate, threads woven through space and time. But what if another loom exists spinning its own tapestry, braiding its own rules beside ours? Not visible, not reachable, until, by chance, those threads cross. Imagine a mirror held to reality, but the reflection doesn't follow. Stars appear, but not where they should be. Particles behave, then rebel, and deep within the math of it all, a question emerges: what if universes can touch, not crash, not collide in fire, but graze just enough for their edges to blur, like frost melting into glass? A ripple here, a shiver there. And suddenly, constants once considered sacred begin to tremble. Cosmologists call it a bubble collision. Born from the early inflation of the universe, pocket worlds forming like droplets in a cosmic foam, expanding, drifting, and sometimes meeting. If our universe is one bubble in a vast inflating multiverse, then others drift near silent, immense, and possibly impossibly close. And in one impossible instant, a brush, a whisper, a tremor in the structure of everything. What would it feel like to live inside a scar left by another universe? And what happens when the physics of two worlds no longer agree? The equations, it turns out, have already begun to argue. It started, as many revolutions do, in silence. A single equation, refusing to behave. A particle spinning left, then right, then left again, as if it could not decide which universe it belonged to. Cracked open the atom. Physicists were met not with certainty, but with shimmering probabilities. Electrons that existed in clouds of maybe, photons that acted like both waves and particles till watched, then came entanglement. Two particles born together, separated by light years, yet forever linked. Measure one, and the other changes instantly. Einstein called it spooky action. At a distance, but perhaps it was more than spooky. Perhaps it was interdimensional whispering. In the 1950s, Hugh Everett stepped into this storm of mystery. He was young, brilliant, and unwilling to accept the standard answer that quantum collapse was simply a matter of observation. Instead, he proposed a bolder vision, the many worlds interpretation. Every time a particle chooses a state, the universe splits, not metaphorically, literally. Each possibility becomes real. Each outcome, a world dot. Every coin toss births a cosmos. Every breath divides the path, an uncountable orchard of realities, each branching from a single unseen root. At the time, Everett was dismissed. His ideas were too strange, his mathematics too bold, his implications too vast. The physics community turned away. But not all. A quiet furibles, theorists, dreamers held on to his vision. And in the decades that followed, new data began to crack open old doubts. The clues didn't shout, they whispered. Fluctuations in quantum fields that seemed too precise. Anomalies in particle experiments, slight but persistent. Patterns in chaos, mirrors that shouldn't reflect but sometimes did. In the quiet corners of particle accelerators and radio telescope arrays, scientists watched for echoes. One group studied ultra-high-energy cosmic rays, particles slamming into Earth's atmosphere with more force than known astrophysical objects could explain. Another team, working with the Planck satellite, mapped the cosmic microwave background, the ancient afterglow of the Big Bang. And there, nestled within the pattern, they found cold spot, colder than theory allowed, too large to ignore, too symmetrical to dismiss. It wasn't just empty, it was foreign. Some believed it to be an artifact, a flaw in the data. Others saw something deeper, a wound, a bruise left on our universe by something brushing against it. If Everett was right, and the multiverse is real, then perhaps some of those branching worlds don't drift away forever. Perhaps the foam of existence lets two bubbles meet. In 2007, cosmologists Stephen Feeney and Matthew Johnson published a model suggesting that signs of universe collisions could, in theory, be embedded in the CMB. Like overlapping ripples in a pond, a cosmic encounter would leave a telltale ring, circular patterns, statistically rare, etched in the oldest light. The cold spot, it matched, not perfectly, but eerily close. The possibility sent tremors through the scientific community. A mirror that shouldn't reflect had flickered, and on its surface, we saw something that wasn't. Other theories compete. Maybe it's just a statistical oddity, a void an immense 1 billions of light years across. But the odds are thin. And the feeling is deeper than data, because it fits a pattern of particle spins gone awry, of quantum entanglements that feel more like messages between versions of the same universe. Perhaps the quantum world doesn't merely hide information. Perhaps it leaks, spills, across barriers. We've yet to define dot, and if these fractures exist, if cosmic maps reveal wounds and wanderings, then the next question is not if, but how many. How many versions of Earth? How many timelines with slightly different stars? How many Milky Ways, drifting in the shadows of our own, just one breath removed from perception? There are physicists who believe we may never detect another universe directly. The walls may be too thick, the rift too rare, the signal too faint, but still, the numbers drift. Still, the reflections shimmer, and deep beneath the equations, a strange harmony persists, as if all realities still hum to the same invisible key. So the question grows louder in the dark. Are we a lone verse in a cosmic song, or merely one harmony in an infinite chord, briefly brushing its echo? And what happens when two songs overlap and begin to resonate? The universe has rhythm, a cosmic tempo drummed into the fabric of space-time itself. Gravity hums, light pulses, time flows smooth, continuous, obedient. But sometimes the rhythm falters. A pause, a stutter, a skip, as if reality itself is momentarily confused. We live inside a memory of the beginning. The cosmic microwave background, the oldest light in existence, is a fossilized echo of the Big Bang. It ripples gently across the cosmos, a near-perfect veil of warmth, uniform in all directions, except for the places it ISN single quotes. The cold spot, a region in the southern sky where the background radiation plunges below what theory allows. Not slightly, but strangely. Anomaly, they called it. Artifact. Coincidence. But coincidences rarely leave scars. It was first spotted in 2004 by NASA's WMAP satellite. Then again, with greater detail, by the Planck probe. It wasn't a glitch. It was real. A circle, vast, cold, and hauntingly precise. Theories swirled. Some proposed a supervoid, a vast region of space nearly empty of galaxies, a cosmic desert, robbing the background light of its warmth as it passed through. But the void, if it existed, wasn't big enough, and the pattern wasn't natural. It looked imposed, as if something external had pressed its fingerprint into the sky. When the whispers returned, bubble collisions in the early universe, during a fleeting moment called cosmic inflation. Space expanded faster than light in explosion, not of matter, but of the vacuum itself, a quantum froth, wild and chaotic. In this turbulence, multiple bubble universes could have formed, each inflating, each isolated, each with its own physics, constants, and destinies. Our universe may be just one of them, an island in a sea of quantum foam, and like soap bubbles blown into the air. Sometimes, those islands drift close. If two universes collide, the event is not a firestorm, but a rewriting, a war of physical laws, an intersection of space-time, scripts, and the place where they meet. It becomes a scar. That's what some believe the cold spot is, a wound left by another universe brushing against ours, leaving a deformation quiet but immense. In the oldest light, we know mathematical models support the idea. Stephen Feeney and colleagues from University College London ran simulations of bubble collisions and their effects on the CMB. The result, circular temperature patterns, faint but distinctive, exactly the kind seen in the cold spot. Other collisions might have happened too, but they would have been erased, washed away in the blinding heat of the early universe. Only those that occurred just before the inflation ended remain. This changes everything. Because if we've found one scar, then there may be others. And each one could be the story of another universe, with its own time, its own gravity, its own light, touching ours, then vanishing again into the dark. But what happens when the contact isn't passive? What if, instead of brushing gently, a parallel world presses hard against ours, not as a ripple, but as a rising tide? Physicist Anthony Aguirre has explored this scenario. He describes domain walls between universes where the physics of two realms clash. Matter may cease to function. Time itself may collapse inward. Even the vacuum, the stage upon which all existence performs, could be replaced by a deeper, more stable version. It's called vacuum decay. And if our universe is a false vacuum, a local minimum in the energy landscape of reality, then contact with a more stable universe could cause our laws of physics to be rewritten. Instantly, not violently, not with warning, just gone. No light, no fire. No time to know, but not all interactions are catastrophic. Some may be subtle, gravitational anomalies, quantum interference patterns that shouldn't exist, like two radio stations bleeding into each other on a single frequency. There's a fringe idea in theoretical physics called brane-world cosmology. In this model, our universe exists on a three-dimensional membrane or brane, floating in a high space. Other branes may drift nearby, close enough for gravity to leak between them, close enough to touch. This may explain why gravity is so weak compared to other forces, because it's being shared, pulled, tugged into neighboring dimensions. True, it opens the door to unimaginable consequences: microscopic black holes, extra-dimensional resonance, particles vanishing from our brain and appearing on another. A cosmic conversation held in the silence between worlds. These aren't just wild dreams. The Large Hadron Collider once hunted for these signs. So far, nothing definitive has appeared. But that doesn't mean they aren't there. It just means we haven't listened deeply enough. And then there are the reports. Anecdotal, unverified, but eerily consistent. Astronauts describing sensations of missing time, observers feeling as if the stars shifted when they looked away. In quantum laboratories, interference patterns changing without explanation. Not violations of physics, but symptoms of overlapping worlds. Even consciousness has become suspect. Some theorists speculate that human awareness might be entangled across versions, that déjà vu is a momentary sync between divergent selves. Of course, science demands skepticism. Most of these are noise, statistical anomalies, imagination, dressed in science. But if even one is real, then the veil between realities is thinner than we dare admit. It brings us to a final, unspoken terror. What if we've already collided and simply don't know? What if the physics we now call normal are remnants of a patchwork, stitched together from different laws and something else? After all, the constants of nature, Planck's constant, the speed of light, the mass of the electron, seem arbitrary. Why these values? Why this arrangement? What if they weren't set by chance, but by compromise? The result of two realities finding common ground in the chaos of contact. It's a fragile piece, one not written in fire, but in friction. And we, the accidental children of such an event, carry the scars in our atoms. So when the cold spot stares back at us from the sky, it may be more than an observational oddity. It may be a mirror. Not of ourselves, but of what we almost became. Somewhere, another world may be watching the same scar, wondering what we are. Wondering if the tremor they felt was us brushing past their laws of nature. And in that fleeting moment when two realities kissed, what secrets were exchanged? Before the silence returned, there are shivers beneath things we call solid. Beneath the laws we trust, the constants we measure. The space between atoms and the time between seconds, there is motion. Trembling, a hush that's not stillness. But the silence between overlapping songs. Perhaps what we call the laws of nature are not universal truths, but local customs set by consensus, then subtly altered by unseen visitors. A collision, not of galaxies, but of frameworks. One reality brushing, another rewriting, the rules in whispers, not war. And maybe we are that whisper. Maybe our universe was never meant to be the way it is. Maybe we're living in a compromise, a patchwork stitched together from two conflicting truths that happen to touch, then froze in place before they could finish the sentence. Some physicists speak of the multiverse with cautious awe. Others reject it outright: too many untestable variables, too much room for fantasy to wear science as a mask. But still, the shadows remain. The cold spot, the quantum oddities, the gravitational drift, the way particles sometimes behave as if they remember other choices. And then, there is us. Human experience is not a precise measurement, but it is a persistent anomaly. Déjà vu, the dream that feels too real. The pull toward choices we never made, but somehow mourn. What if these are not errors in the brain, but echoes? Faint signals from nearby timelines bled into ours through fractures we haven't yet learned to see. We tell stories of parallel lives because something inside us recognizes the shape of what we've lost, or missed, or never had. But someone else did, in quantum theory. All possibilities are real. In relativity, all times exist at once. Combine the two, and you arrive at a universe that is both deeply stable and utterly uncertain. A place where everything that can happen does. Somewhere, and where every now and then do something's overlap. If collisions shaped our past, could they shape our future? What if contact comes again, not as light in the sky, but as a sudden unraveling of what we thought was real? The change wouldn't come with thunder. It might begin with a small discrepancy, a particle refusing to behave, a planet wobbling, slightly off course, a person remembering a life that never was. Then the constants shift, gravity loosens, time stretches, space forgets what shape it should be, and we born from one collision might vanish inside another. But maybe that isn't an end. Maybe reality is not a line, but a sea of merging rivers, and we are droplets, carried toward something wider. So listen closely to the stillness. It may be the breath before another world brushes ours. Not to destroy, but to remind us that even reality can remember a different shape.